Okay, yeah, as you've heard, I'm Tilman. I'm here with Data Scientist Xto. Right now, my official job title would be something of data consultant. So I'm working with our customers to improve their data science processes and their data pipelines. And I want you to imagine the following. Yeah, you're a data consultant just like me. You're working at a customer for department A of that customer specifically. Keep that in mind, it's going to be important. And you just completed your first data project. Pipelines are running, models are humming, and now your last task is present what you did to the team of Department A. How are you going to do that? Are you going to do a PowerPoint? Nah, static, boring. You're a consultant, but not that kind of consultant. Are you going to show your command line? No, like there are non-technical folks there, like they're just going to shut off completely if you're showing like command lines. You should do an interactive dashboard. It's bright, it's colorful, it's on the web, like everybody loves interactive dashboards. But how are you going to do that? It has to be quick and dirty. Streamlit. Obviously. Who has heard of Streamlit? Okay, nice. It's the best in the biz, battle tested, lots of integrations. You can do all the plotting you want. But you've also heard of this new framework. It's really, really fresh. It's FastHTML. Who has heard of FastHTML? Who was confused because it sounds like Fast API? Yeah, me too. It sounds really interesting, but you are no web dev. Like, this is a web framework. Like, you never work with Django. How you can? Is it for you? Is it for you as a data person who just dabbles in this web stuff? The docs say, like, FastHTML excels at building dashboards. Today we're going to find out. We're going to split the timeline and see what would have happened if you'd chosen Streamlit or if you would have chosen FastHTML. And just a quick disclaimer, I'm not a hater. Like, I love Streamlit. I even brought my special Streamlit socks for last year's conference. Fucking limited mobility. So we're going to see how it works out. How are we going to do this? Am I going to show you a PowerPoint? No. Am I going to show you a console? No. I'm going to show you an interactive dashboard. This one. And I'm just going to refresh it really quick because resolution changed. What you see here is on the left side, that's FastHTML. And on the right side, that's Streamlit. And here below, we've got the code of the app that is running right now, so we can see the output and the code of it. Okay, so first thing you have to do is you have to show the team the data that you worked in. And we can all collectively pretend that this is not the iris data set, but something interesting, actually. And we need to load the data for this plot, this scatter plot, from a blob storage or like Iceberg, whatever. That takes a while. And we're going to simulate that, in this case, with a function that has a big old sleep command in it. So I'm not really loading data. But it's still enough to see how it will work. Okay. So first, let's have a look at Streamlit. This is Streamlit. I'm just going to refresh this here. And you see it says running an expensive calculation. And there it is. This is our plot. Has highlighting here. Everything works. And it's really, really simple. So this is all the code that I needed. Streamlit always runs the script from the top. So the first thing you have is the title, then the text, then the plot. And every time one of these commands is executed, it's immediately reflected on the UI. So that at the time that this title here is executed, you see it on the UI. So you've got this really nice lazy loading thing where you can see something, but the script is still plotting and fetching data and stuff like that. That's really nice. On the other side, we have FastHTML, and for you to see it, how it works, I have to refresh the whole site. So please focus on the left. You see nothing, you see nothing, you see nothing. There it is. So FastHTML is root-based. Anyone who has seen like a Fast API app or a Flask app knows how to read this, I hope. So we have this root here, it's the index root, and we can call it with a get command. And we are building the website, like we're building HTML directly with these fast text. That's what they are called. And the thing is, because it's root-based, you only see something when the root returns. So this is going to get rendered, and then you see something. So first drawback for FastHTML here, it's a little bit more code, and you don't get this nice lazy loading. Like, if it takes a while for your data to load, people will just assume your dashboard does not work. That's not good. So next, we're going to see if we can replicate this lazy loading in FastHTML. And as you can see here, we've got a little spinner, and there it is. I can just do it again for you to see. There it is. Spinner, 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 and there's our plot. So that's much better. How did we do that? So FastHTML is based on HTMX, which is basically a JavaScript framework where you don't have to write JavaScript, which is always great. And the main point is that you can just swap parts of your HTML in and out. So what we do here, instead of directly rendering the plot, we are rendering a placeholder that immediately when it gets loaded by the browser calls the plot root, and the plot root then generates the plot and swaps out the placeholder. And with this area busy, we're not only getting this nice spinner, but a little bit of accessibility too, which is also nice. Okay, so with that, we have feature parity now. Like you see, it looks a little bit different because Streamlit has this Plotly integration and everything. It looks a little bit more coherent, but otherwise, both things do exactly the same. Speaking of integration, as you can see here, with Streamlit, you can just call the Plotly chart function and give it a Plotly chart. It's just throwing it on the UI. With FastHTML, you need a third-party integration package, which is called Plotly to FastHTML, which has the same functionality. You just need to give it the Plotly headers to load Plotly on the client side. And then you have this Plotly to FastHTML function which does exactly the same thing. Yeah, but integrations are a little bit more bumpy here because, yeah, Streamlit is around since, I don't know. And yeah, FastHTML is around since last June, actually. So the ecosystem is still growing, basically. Okay, you've got your plot, you've got your lazy loading, but actually you wanted interactivity, so you want a drill down. You want to click something on your first plot and get a second plot that shows some detail. Okay, we're just going to check out how it works. So here in FastHTML, I'm just clicking something, and below here, I see which point I selected, and I have this bogus data that I made up, which is like the details of whatever point we selected. And we can do the same thing with Streamlit, and it works quite slowly. Why is that? Here on the other side, we have instant reactivity. We can click, and there's the plot. And every time we click on Streamlit, it starts to load again. What is it doing? Streamlit always runs from the top. So every time you change something, which we're doing here, we're getting this event from the Plotly chart. And if in the event some point is clicked, we're actually computing this other plot. But every time we click something, it's running from the top and recomputing, refreshing the data from our blob storage to get this first plot. That doesn't make sense really, but this is how Streamlit works. This is the simplicity of it. But in this case, because we have this long-running function, it's really downside. So how did we do it on the other side? We use this onClick callback and just say, okay, send a post command to the details route and target the details container. The details container is here. It's, again, just a placeholder where we can swap in other content later. And then we have the details route, which takes X and Y value and then creates another placeholder so we can get this lazy loading spinner again. We don't really need it here because it's instant. But we still do it. And then we have this details plot, which gets called from the placeholder details to actually swap in the plot. So we have a little bit more code again here on this side, but through this root system, the control flow is still clear. And we've got this instant reactivity because every time we click something here, you can see the selected points changing below because it doesn't recompute the first part, because why should it? It's not really necessary. But of course, the Streamlit people thought about that, like this is not an uncommon problem. That's why they introduced caching. So what we did here is we wrapped our plot function in stCacheData. So each invocation of this data is of this function is cached actually. So when we first click on here, it's going to take a while, but now it's instant because this plot here is not actually calculated, it's just cached. That's all fine and dandy, but as you know, there are two hard problems in computer science, and one is naming things and the other thing is cache invalidation, and I really like that I can give this saying referring to the cache invalidation, not to the naming things. Yeah, this will be a problem when you have some kind of live data, because you are now caching the call for user interaction, but you do not know is there any new data. So when I refresh this page, it's still the old data. If you have, if your data is changing, you refresh the FastHTML page, you get the fresh data. If you're now refreshing the Streamlit page, you get the stale data. In our case, it doesn't matter, but it's something to keep in mind. If you're using this caching functionality, you need to think about when do you need to invalidate the cache. Okay, now you're ready to present. Your team is impressed. Your boss is happy. And now he wants this demo to be deployed for everyone in Department A to play around with. But your boss says, not Department B, because Department B people are jerks. Damn you, Department B people. So you need a login, something to keep Department P out. Okay, how do we do that? We will just add this sidebar with a nice login interface. You can see we replicated it for both of our apps, and we're just going to type in our really complicated password. And here's our app. And then we're going to type in our other really complicated password, and we're in 2. Okay, was that hard? So for Streamlit, here's where it gets complicated. As you can see, the code blew up a bit. And what we want the code to do is basically, if you're not logged in, show this sidebar with the login stuff. Then if I click login, collapse the sidebar and show the actual content. And how this works is I have to set this session state for this sidebar to be expanded, but I also want to retain this state over multiple reruns of this script. So I need to use this session state here and then set the page config. And then with this sidebar, I can build the input, the login form. And this here only runs if I submit the login form. And then I have to call strerun, which is basically a goto. And if anybody of you has heard the talk on exceptions being gotos, you know why gotos are not exactly a nice thing. But this is what you end up with. If you want to stop the execution of your notebook somewhere, of your script, and then go from the top, you have to use this rerun, because if we log in, we set in the session state this token that we get from the user login, and then we go from the top again, and here in this state, we then read the sidebar state that we set down here to set the page config, so the sidebar then collapses, and then we can check down here if the token is present and render the actual content. Did everybody get that? It's not that nice to read, actually. Okay, how did we do it on the other side? So just ignore this. This is some custom CSS to make the sidebar go whoosh. Yeah, this is not really needed, actually. What we need is this down here. So we extracted some components. So everybody who has seen like React or something like that knows what this is. So these components are just reusable UI elements here. So we have our layout here. We have the title of our app. We have the sidebar here that can contain something. And we have the main content here that contains the content. So I can call this layout and set the content and the sidebar separately. Then I have the main content here, which is exactly the same thing that was in the route down here. And I have the login sidebar stuff, which is basically just the login form. And down here, I have an if. I have the user in the session, which means that the user is logged in. I show the main content. And if it's not there, I'm showing the login page with the login sidebar. And then I have this login post method down here, which basically does the login. And then if it's successful, it swaps out the dummy content in the main page with the main content. And it swaps out the login form with nothing, a placeholder that is just empty. And the rest is the same. So just to show it again. No, I don't want to save this password, actually. We have to go back and then again to get the login. There it is. So this is what happens. We have the login in the sidebar and this dummy content, then we log in. And when I press this button and the login is successful, it's going to swap out this content, so it's nothing, and the bar collapses, and it's going to swap in here the main content. It gets a little bit time to get used to this style of coding, but having these routes, in my opinion, makes it much more readable than this conglomeration of if statements and reruns. Also, this here is really hard to debug. And this here, you can just open the developer tools in your browser and see which route it gets called and so on. So in my opinion, the authentication side is where Streamlit starts to break down, actually. Okay. You're good to go. You deploy your app. Everybody's happy. The whole department, they love it. What now? Your boss comes to you and says, "Yeah, actually, I'm getting really old. I can't read it anymore. Like, can you add a slider to, like, make the scatter plot bigger?" So yeah, no, sure, let's do it. So in your app, we have to log in each time now, unfortunately. You have a slider here. It works. Just in the sake of time, I'm going to speed up a bit. It makes stuff bigger and smaller. Your boss is happy. No, actually, he's not happy. He says, "Who puts the slider above the plot. I want my control elements below the plot like a normal person. Can you do that? And you're like, yeah, boss, whatever you say. So you try that, and actually, this is really hard in Streamlit, because as you know, things go top down. So if you want something below something else to influence it, like it's not even declared when the plot is rendered. So how do we do that in Streamlit? We have to set this marker size state before the plot calculation is running. And then down here, when we define the slider, we have to tell it, okay, your value key in the session state is this, so that Streamlit then knows that this value in the session state that is persisted between reruns belongs to this slider below the plot. And how to do this is in the Streamlit documentation under advanced topics, and I find it confusing that I need to employ advanced techniques to have a slider below something. Okay, how does FastHTML does it? Like, it doesn't change really. We take this slider, where is it? Here, it's input type range, and we just moved it from here to here, and nothing else changes. So it's like this was the part where coding it in Streamlit took more time actually than coding it in FastHTML. And this is like this kind of famous plot where you have 2 lines, and first Streamlit is much easier, you're much faster, but at a certain point, FastHTML just overtakes it because your interaction gets much more complicated. Okay. Now, your colleague has a nice data project too, and the boss says, yeah, you know, you already have this like dashboard. Can you just integrate their work into your work? And you're like, yeah, whatever you say. So we need multiple pages now. And how do we do that? In Streamlit, you can do that. I have to be really precise to not hit the reload button. So in Streamlit, your navigation is always in this sidebar, and you can just switch pages here. So this is a subpage. In FastHTML, you can actually put it anywhere. So for example, here on top. And now it's not working, nice. Okay, so you can put it anywhere. And how would you do that in Streamlit? In Streamlit now you have to refactor your whole system to put your old code into functions or into separate modules that can then, below here, be put into ST pages. These ST pages get put into an ST navigation, and then you have to run these different navigation thingies depending on if you're authenticated or not. So things get even more complicated. What do we do in FastHTML? In FastHTML, you build a navigation, which is here. It's just a list with like class dropdown, so it looks nice. And then you have an additional route that is just a subpage. So I changed nothing, but just added the subpage. This is how it should be, and not like refactoring the whole project to just add a second page. Yeah. Okay. Because I'm nearly out of time, I'm going to skip improved authentication and go over to the conclusion. What should you use, actually? So Streamlit has the upper hand when time is of the essence. So it gets you started fast. As you saw, to get something, it was 5 lines of code. And FastHTML first needs some boilerplate, like setting up all the routes and stuff like that. Yeah, Streamlit, all in all, even when it got harder to develop, there was less lines of code actually. Like it was like 2 times the lines of code in FastHTML. In Streamlit, you have many third-party integrations. FastHTML is lacking, but it's actually getting better. Yeah, and in Streamlit, the whole page refreshes every time. In FastHTML, you can be much more granular. Streamlit control flow gets confusing. Road-based control flow of FastHTML, in my opinion, is much better. And one of the important things I think here is using Streamlit teaches Streamlit, nothing else. But using FastHTML actually teaches you web fundamentals, because FastHTML is standing on the shoulders of giants. It doesn't reinvent something. It's just CSS, HTML, and a little bit of JavaScript that you hopefully do not need to write. But this is transferable knowledge. You may not be a web developer, but at least you know something, yeah? You know T-shaped mindset? Yeah. Okay, so my verdict is, if you're gonna throw it away, if you need to do it in a day, Streamlit, everything else, FastHTML. Thank you.
All right, thank you for the talk. Thank you for the earworm. I'm going to repeat that before I go to sleep today. We do have a few questions, and first of all, let's start with, what is this black magic where you compare to web apps or web code below?
It's FastHTML. Like it's just a FastHTML web app that starts another FastHTML web app as a subprocess and the Streamlit app as a subprocess, and then shows it in an iframe and basically reads the code of the file and just displays it. And the switching is basically just Git Python in the background, checking out another commit and then reloading the page. It's nothing else.
All right, can I easily extend FastAPI with FastHTML?
No, they are not compatible. They are both based on Starlet, so they have the same base, but they're yeah, it's not really compatible. You can actually use HTMX, one of the base components of FastHTML, with FastAPI, but like the developer experience is a little bit smoother in FastHTML. So this is the difference. Like FastAPI is for APIs that return JSON or something, and FastHTML is for returning web apps with HTML responses.
Would you recommend FastHTML for more sophisticated apps, maybe even customer-facing or just internal ones?
Yes, definitely. At DataSiders, we're building a tool right now for internal use, but maybe we're going to sell it. We are not sure yet. But this is like medium complexity. We have at the moment like 2 or 3 users, but it's going to scale. And it has a lot of interactivity, and we build it in FastHTML, and we have yet to hit the wall where complexity gets unbearable.
Right, potentially last question. Among the many web frameworks that were the main reasons to use FastHTML or Streamlit, did you also consider other frameworks such as Dash?
To be honest, no. Like the main reason that I chose FastHTML was because I wanted to try it out, and I read a lot of HTMX, and like people were like hyped about HTMX, and FastHTML gave me a really convenient way to use it from Python. So yeah, like this is not a scientific comparison. This is pretty biased.
All right, and with that, we have to wrap. We're out of time. Thank you again to our amazing speaker.